Requirements are the backbone of a software development project. Architecture is what provides that project's skeleton. Visual Studio 2010 provides support for both. Let's start with requirements. Requirements drive the design and development of an application. They determine what tests are done, and ultimately, they're fundamental in deciding when the project is done. Managing requirements effectively is important. VS 2010 does not specify how requirements should be gathered. You are free to use Microsoft Word, any tool you like to do this. But once you've got them, requirements are stored as work items in TFS. A primary goal of VS 2010 is to provide requirements traceability, letting people on a team connect requirements with other aspects of a project. To make this possible, requirements can be connected with other work items like tasks and test cases and bugs. This lets team members do things like figure out which requirements don't yet have any test cases, or work out who's been assigned the tasks for a certain requirement, or even decide what test to work on today based on what is now the highest priority requirement. TFS allows working with requirements in lots of different ways. For example, a developer might use the Visual Studio IDE to see which bugs are tied to a certain requirement. A tester can use Microsoft Test Manager, MTM, to display the tests for a requirement, and a business analyst might prefer to see requirements in Excel, letting her list the tasks for each one. Here's an example of how that looks in Excel. The requirement, the user story, in the parlance of agile people, the requirement for others, is shown here. The tasks associated with it are right beneath it. Through Excel, it's possible to see these, to modify them, to update them, and store the results back to TFS. Excel provides one of many tools that allow access and visibility into this TFS data. The big goal, the overarching goal, is to allow requirements traceability throughout the development lifecycle. Requirements are important, but so is architecture. Exactly what people want for architecture tools varies quite a bit, and so VS 2010 includes several different things. For example, it provides tools for UML modeling with support for class and sequence and use case activity component diagrams. A UML diagram can be linked to a TFS work item too. So, for example, a use case diagram might be linked to the requirement it's associated with. The product also includes tools for design and visualization. It's possible, for instance, to create layer diagrams that partition an application's code into discrete chunks that enforce that partitioning. Here's an example. Suppose you've divided your code into the classic three layers: presentation, business logic, and data. And suppose the rule you want to enforce is that presentation logic only talks to the business layer, which in turn only talks to the data layer. You can't go directly from presentation to data. Well, by dragging and dropping pieces of your code into the various parts of the diagram, you can construct what you see here, a layer diagram. And this is useful for documentation, but it's more than that, because this is not just documentation. In fact, you can construct, for example, what's called a build verification test, a BVT, where after a build is done, it verifies that the rules expressed in this diagram are followed. This is not just documentation. This can be enforced. And that means that the kinds of architectural drift that tend to happen over the long term while apps are being maintained can be much more controlled. Someone can't just say, oh, let me tie a presentation right to data for this one thing. It won't pass the test. VS 2010 also provides a tool for creating and working with dependency graphs. A dependency graph is just what it sounds like. It's a graph that shows how various parts of an application depend on one another. Here's an example. What you're seeing here is an assembly full of classes. Links between the classes are shown by lines, and the thickness of the lines indicates how many connections there are between those classes. You can search for things like a certain name or identifier. And, best of all, you can't tell this from this diagram, but in fact, this tool is interactive. You could move around, zoom in, zoom out, work through the code to understand it in a big picture way. There's a bunch of cases where this might be useful. For example, suppose a new guy joins a development team. They must come up to speed on this large code base. They can always just read the code, but given how visual we are, why not use a visual tool like this to help them understand? Or think about maintenance. In a maintenance scenario, people often have to understand a new code base quickly. A tool like this could be useful for that, helping them understand what links to what and making fewer errors where a change here breaks something unknowingly over there. Every project has requirements, and managing them well is important. Every project has architecture, the thing that provides its structure. VS 2010 includes tools to help work with both of these things, the backbone of requirements and the skeleton of architecture. They're essential parts of the development process.